So, good afternoon. We're going to continue on working with the chorded plane. We're going to build into a new topic called graphing linear equations. So, notice how you have this linear equations. We may see that word line in here. It's going to kind of give us a hint on where we're going with some of this. One thing we want to pick up on in geometry it takes 2 points to actually create the direction of a line. So if I put a point here and a point here, notice that I can only draw one line through those two particular points. So that's going to be a unique line. So if I want to create a unique line, I need two specific points, and then there's only one way to draw that line through those 2 points. So it's going to be unique. So getting into linear equations, what we pick up on is we're going to have two variables here. We're going to have an x value and a y value in this problem. So again, linear equations are going to have this two variable concept in them. And most commonly, you're going to see the x and the y. These letters could be anything, but you're going to have two different letters. Since this is an equation, equations have solutions. What I want to do is identify all the solutions to this equation. So I want to identify all the solutions to this equation. So, looking at what can you add to another number to get 5, well, to me, the obvious one that jumps out at me is if I have x plus y is equal to 5, try that again. I could say, well, if x is 0 and y is 5, that would be a true statement. So if x is 0, y is 5, if I replace x with a 0 and I replace y with a 5, 0 plus 5 does give me, try that again, if you put a 0 there. 0 plus 5 would indeed be 5, and that would be a true statement. So 0, 5 would be a solution. So I can write that solution in the form of an ordered pair. Okay? So 0, 5 would be a solution. So 0, 5. Notice how I can also order this in what we call a table. Some people call them T-charts. So I have the x value corresponding to the y value. 0 goes with the 5. Looking around here, I can also see that, 2 plus 3 is 5. So that tells me that 2, 3 is another ordered pair. So notice that with these types of equations, we're getting more than one solution. Remember before when we solved for x, we got x equals a specific number. But now, when you put two variables involved, there's going to be a few more choices involved here. So also pick up on this, I got 1 plus 4 is 5. So we pick up 1, 4 as an ordered pair. So I can write that in my table. And these aren't the only solutions. I could actually think in terms of fractions and decimals if I want to. If I had like 4.5, if I had a 0.5, that's going to give me 5. So 4.5, 0.5 would also be a solution. I could even get into negative numbers. I could say if x is -1, y would have to be 6. -1 plus 6 would also give me a 5. So I have that 4.5, 0.5 there. I have a -1 and a 6 there. So through my reasoning, what I'm picking up on is, wait a minute, there's going to be a lot of solutions here. So that's why we get into graphing linear equations. Since I can't really write all the solutions out, what I want to do is describe the solution set. I want to describe that solution set. And that solution set is going to be portrayed by these ordered pairs. So I want to put these ordered pairs into my graph. So I have a 0, 5. So 0, 5 would be here. I have a 2, 3. 1, 2, up 3. I have a 2, 3. I have then a 1, 4. 1, 4. 4.5, 0.5 would be about here. -1, 6 would be up here. -1, 6. What you kind of see, and this is kind of rough because I kind of sketched this, but you kind of see that these points do kind of follow a trend. they kind of go in a downward motion or even a downward linear motion. So what I'm allowed to do is I'm allowed to draw a solution using a line passing through these points. And that's not a real good line. So what we pick up on is the solution, if I want to identify the solution, the only way I can identify that solution is sketch a line. So I'd have something like that. And that's not a real good job, but that's where real graph paper would take advantage of things. So when it comes to identifying the solutions, what you have to do is actually graph the solution. So here's what we want to do when we have problems like this. I want to find 3 solutions. So I want to find 3 solutions. So, like right here, I have these 3 solutions. Preferably, you want nice, clean whole numbers. Fractions and decimals are really hard to plot. I think that's what's getting me a little trouble here is some of these fractions and decimals. So I found 3 solutions. Also, you want to organize these solutions in the form of a table, which we did. We want to plot those solutions on a graph. And then you want to draw a line through those points. And when you draw that line through those points, that represents all the solutions to this equation, which means any point on that line is going to be something that makes this expression true. Okay? So that's some food for thought. Let's see if we can put another example together.